Moving on, students, we'll be studying one of the most important effect of this chapter, and if I have to tell you, this is the heart and soul of the chapter, this effect which is called as photoelectric effect. And to study photoelectric effect in detail, we need to understand the definition about photoelectric effect. And the definition goes something like this. It says the process. So it is a photoelectric effect. That means it is going to be some kind of process. So it is a process of emission of electrons. That means electrons are not remaining, they are getting emitted. So it is a process of emission of electrons from the metal surface when light of suitable energy. Now it is not a less energy, it is a suitable energy above a certain value falls on the metal surface, and that effect is called as photoelectric effect. I would like to repeat, students, it is a process of emission of electrons from the surface of a metal when a light of suitable energy above a certain value falls on the metal surface, and that effect is called as photoelectric effect. To understand photoelectric effect, I know you all are still confused. We will look ahead to see this whole concept with the help of an example. So let us study now the photoelectric effect in detail. Let us consider a metal plate, any metal plate which is there in front of you. You can consider that metal plate, and every metal plate, as we all know, consists of lots and lots of free electrons. So this metal plate also has many number of free electrons. What do free electrons do on a metal plate? The electrons have a tendency to perform random motion. And as you all saw, that the electrons perform random motion. These electrons also have a tendency to start getting excited when they receive a certain amount of energy. Like students, you start getting excited whenever someone cracks jokes in the class. So even like those electrons, they also have a tendency to get excited when they receive a certain amount of energy. Now what happens when they receive certain amount of energy? We know, according to Planck's quantum theory, that energy, when it comes in the form of light, it is in the discrete packets form, that is in the form of bundles, that is quanta or photons, and not in the continuous form. And we all know that the energy of the photon which is coming and getting incident on this metal plate will be given by E is equal to h nu. And since the metal has lots and lots of free electrons, the free electrons will come out of the metal surface only when they get certain amount of energy. Imagine if they want 50 joule energy and I'm giving only 40 joule, will they come out? No, they require that 50 joule, then only they will come out. So can I say the minimum amount of energy which is required for photoelectric emission to take place or photo emission to take place, this minimum amount of energy is given a new term and it is called as work function. So the minimum amount of energy required for photo emission to take place, students, is called as work function. Different metals, students, have different work function. That means, can I say work function is a property of metal? If I keep on changing the metal, the work function will also keep on changing. Like it will be different for gold, for steel, for aluminium, and for different metals. So now we got to know what is work function. Now imagine the light which is incident on the metal surface, which has to have a certain amount of energy which is greater than the work function, because work function is that minimum energy required for photo emission to take place. That is why I consider a light source which is emitting light on the surface of the plate. Now that light, you can see, is coming and getting incident on this plate. And that energy, I tell you, is the energy which is equal to the work function. All the electrons on the metal surface will receive that energy, will absorb that energy. Yes, students, they will have a tendency to start getting excited. They will get excited and you can see the photons coming and colliding with the electrons getting excited, and electrons will have energy in them and photo emission will take place. So students, this is how the photoelectric effect takes place. Thank you.